Hello students, welcome to this video in which we will solve question number 461 to 470. The link to download the PDF will be in description, as well as at the end I will show you how you can maintain updated copy of the PDF. I will also show you my question answer website which I have developed for you, where you can come and ask questions, because YouTube comments boxes are not quite suitable for asking mathematics questions or answering mathematical um, content. So without further ado, let's get started. Question 461 says that how many integers from 1 through 999 do not have any repeated digits? So we have the answer here. If the integer is of 1 digit, then there are no repeated digits. If the integer is of 2 digits, then we can fill first position in 9 ways excluding 0 and second position in 9 ways excluding first digit, which gives us 81 integers. Similarly for 3-digit integer, we have 648 digits without repetition. So 648 comes from 9 into 9 into 8, and thus we have a total of 738 integers by adding all this without repetition. Question 462 says that find the number of natural numbers less than or equal to 10 raised to the power 8, which are neither perfect squares nor perfect cubes nor perfect fifth powers. So number of perfect squares is 10 to the power 4, number of perfect cubes is 464, number of fifth powers is 39. The squares, which are also cubes, is 21. Fifth powers, which are also squares, is 6. Fifth powers, which are also cubes, is 2. So this you have to compute, okay? And thus, number of such powers is 10 to the power 4 plus 464 plus 39 minus 21 minus 6 minus 2, that is 10,474, and thus required answer is 10 to the power 8 minus 10,474, which is 99,989,526. Question 463 says that in a certain state, license plates consists of from 0 to 3 letters followed by from 0 to 4 digits. With the provision, however, that a blank plate is not allowed, how many different license plates can the state produce? Suppose 85 letter combinations are not allowed because of their potential for giving offense. How many different license plates can the state produce? So we have the answer here. 0 letters can be chosen in one way, 1 letter can be chosen in 26 ways, 2 letters can be chosen in 26 square, and 3 in 26 cube ways. Similarly, digits can be chosen in 1 plus 10 square plus 10 cube plus 10 raised to the power 4 ways. Thus, number of licenses which can be produced by this combination is 1 plus 26 square plus 26 cube multiplied by the powers of 10. However, one of these contain neither a digit nor a letter, that is, it is empty. So our required number is the product minus 1. Now we know that 85 combinations of letters is not allowed, so we subtract the 85 from this again, and then we multiply, and that's how we get our answer. Okay. Question 464 says that if the number of ways of selecting K coupons one by one out of an unlimited number of coupons bearing the letters ATM so that they cannot be used to spell the word math is 93, then find K. So math cannot be spelled if only one of the letters or two of them is chosen. Number of ways of choosing one letter is 3C1, that is 3. Number of ways in which 2 can be chosen is 3C2 multiplied by 2 to the power k minus 2. Thus, 3 plus 3C2 multiplied by 2 to the power k minus 2 is equal to 93, which implies k is equal to 5. Question 465 says that how many positive integers divide at least one of 10 to the power 40 or 20 to the power 30? We know that 10 to the power 40 is equal to 2 to the power 40 into 5 to the power 40, that is 41 times 41 minus 1, that is 1680 factors. Factors of 20 to the power 30 is 2 to the power 60 into 5 to the power 30. Not dividing 10 to the power 40, you have the form 2 to the power m multiplied by 5 to the power m, that is m will lie between 41 to 60 and n will lie from 0 to 30. Number of such numbers is 20 times 31, the difference between these two, and this 31 product for n, that is 620. Question 466 says that how the number of permutations of letters A, B, C, D, E, F, G taken all together if neither beg nor cad pattern appear. I think there is some typing mistake in this. So let's look at the answer, what that has, and then we will have clarity on this. This seems to be a typing problem. So total number of permutations is 7 factorial. Okay, here also the same problem is there. Looks like a typing mistake, and copy and paste. Let's see, okay. NA, so 5 factorial is that. I will skip this question, okay. We will skip and do it in next video. Let's see, okay. So what we can assume here is, it seems the question is correct. I can't have so many typing mistakes. So what we'll assume that these question marks can be filled by any letter, okay. So we have 5 letters here. So NA is equal to 5 factorial, that is 120. Similarly for this one, we have 120, okay. So both can also come together. So N A intersection B is 3 factorial is equal to 6. All right, by treating both them as one letter. Now NA union B is 240 minus 6, that is 234. And A union B complement is 5040 minus 234, that is 4806. Okay, so the idea is there might be typing mistakes, but to understand the idea of the question is what is of importance. All right. Now 461 is similar question. The word given is the letters of the word Hindustan such that neither the pattern Hin or this or Tan appears. Okay, these patterns should not appear. So let us represent the words in which Hin come together. Treating this as one letter, we have Na is equal to 7 factorial permutations. Wow, 7 factorial. Okay, and treating this as one, we and B is the set in which it comes together. We have NB is equal to 7 factorial by 2 factorial. Okay, now this is beyond me. All right. I have no clarity on this, why this NB would be 7 factorial by 2 factorial. N comes twice. Okay, how come N is 7 factorial? I will have to come back to these two questions later on. Let's proceed with other questions. I'm not very sure about these two questions. Okay, I'll have to refer to my notes, which is in much more detail. So apology for not being able to explain these two questions. Let's proceed with 468. Find the number of permutation of the 8 letters A, B, B, C, C, D, D taken all at a time such that no 2 adjacent letters are alike. So number of permutations is 8 factorial by quadruple of 2 factorial multiplied together, that is 2550. So we have 4 pairs, that's why 4 times 2 factorial has come. Let alpha represent the set where one of the letters come together, then n of alpha is 7 factorial by 2 factorial multiplied by 2 factorial multiplied by 2 factorial, that is 630. Let alpha beta represent sets where 2 letters come together, that is 6 factorial by 2 factorial multiplied by 2 factorial. And so similarly, n alpha beta gamma would be 5 factorial by 2 factorial, and n alpha beta gamma would be 4 factorial. So applying the principle of inclusion exclusion, we get desired result as this 2520 minus this will come 4 times 630, and this will be multiplied. So 6 times, because 6 such sets are possible, 4C2. And similarly, we proceed like this, we get 864. Question 469 says that find the number of non-negative integer solutions of x1 plus x2 plus x3 is equal to 15, subject to the fact that x1 is less than or equal to 5, x2 is less than or equal to 6, and x3 is less than or equal to 7. So we have to find the non-negative values. That means values can be 0 also. Now, what you can observe is that it is like number of ways of distributing 15 among 3 variables. Okay, give me a second. 15 among 3 variables, so that is 136. Let D1 be the number of distribution where x1 gets at least 6, D2 be the set of distributions where x2 gets at least 7, and D3 be the set of distribution where x3 gets at least 8. So D1 is equal to 11C2, D2 is equal to 10C2, and D3 is equal to 9C2. And then we compute intersections of these two, and finally intersections of all three, which would be 0. So we compute the union, which is 126, and then we compute the complement of that, which is 10. So pretty straightforward question. According to the Gregorian calendar, a leap year is defined as a year n such that n is divided by 4 but not 100. N is divided by 400. Divisible. It should be divisible by 400. That's English. Find the number of leap years from the year 1000 to year 2000 inclusive. So number of years divisible by 4 between 100 to 3000 is 501. Number of years divisible by 100 between, this is unnecessary, between given range is 21. Number of years divisible by 400 is 5. So by applying the principle of inclusion exclusion, we have 501 minus 21 plus 5. That is 485 as the answer. Okay, with this we come to the end of this set of problems. I'm not sure about 466 and 467. They may be correct and may be incorrect. This pattern looks like as correct to me. I don't think there is a typing issue. But I do not, this problem I understood, this solution I understood, that how come we are having this, okay? But I don't understand this one at all, okay? The reason is I don't understand how this is 7 factorial by 2 factorial, okay? So it says n comes twice, but I don't see n coming twice here in this. Thus, anyway, I will refer to my notes about this particular problem 467. 466 is fine to me. I'm not sure about this. Okay. I'm not even sure about what the question actually means by question mark. So I will have to refer to my notes. Apologies for not being prepared enough. In any case, let me show you my website. So you can download the PDFs from here, and you see when you download, the dates won't be in the file. So you need to add the dates in the file so that when I update the book, you know that it is an updated version and you can download and update your date. I cannot put date in the actual file which you download, because if I do that, then all the YouTube links will become invalid in case of an update. And I will have to go through all the videos where I have given the link to update the link, which is practically not possible. The second thing is I have developed this question answer website for you guys. You can come here and ask your questions. And for algebra questions, you can use this algebra tag. For trigonometry, you can use trigonometry. For coordinate geometry and calculus, these are the tags. I will add more tags. There will be tags like theory of equations, permutation and combinations, or combinatorics. As a user, you cannot create tags. You will have to use one of the tags which are available to you. So registration is very simple. You can choose a username and email. You'll be sent a link. You click that link, confirmation email, and once you confirm, you will be able to log in. Without confirming, you are not allowed to log in. So log in, you just give your email. On your email, you will receive a code. You paste the code in the next screen and you will be logged in, and then you can ask questions. If you don't log in, you are not allowed to ask questions, although you can read questions and answers. Okay. And your email is very safe. Even I cannot see your email from the user UI. Of course, from the database, I can see all the emails and all that. So make sure that you create a login here if you have questions or you want to help others with the studies of maths or programming. In programming also, I have covered C, C++. Then we have Python, Rust, JavaScript. These are the languages I know, and I'll be able to answer those questions. So with this, I will end this video here, and I hope that you are finding this video useful and informative. So this question 467, we will discuss it again in the next video. Okay. So with this, I will take my leave here, and we'll meet again tomorrow with 10 more problems on permutations and combinations. Till then, I'll say bye to you, and you should keep practicing and have a great day. Enjoy.